Hello. Now we are going to discuss ring counter. So we can have a generalized ring counter which can be configured for any size. So here we have a size parameter to pass the constant in Verilog. So using this size parameter, we set the size of the ring counter. Here is set as size is equal to 4. That means it is a 4-bit ring counter. Then as the input we have a clock signal, a reset. Then output is of size minus 1 to 0 and it is called a Q. Then local variable we have one integer and it's going to be a synchronous ring counter. So we have a always at passage of the clock. So the entire operation is going to be governed by the positive edge of the clock. Then if the reset is 0, Q is set with the initial value. That means output of the ring counter is set with the initial value 1000. So then if the reset is changed to 1, then the ring counter operation exactly starts here by moving Q of 0 to the Q of size minus 1. And once when this direct transfer is done, next, what we are going to do is we are going to do the right shift so that the contents will be shifted one by one. So for this, we use one for loop over here. So this will go starting from 0 to n minus 1, less than I less than n minus 1, that is size minus 1. So every time it will shift the value from I plus 1 to q of I. So that basically produces a shift in the shift register content. And now we have a series of ends here for the for loop and for else and for always, and for the end module we have a end terminating statements over here. So once this is done, next we go to ring counter and we will compile and then we do the compile selector. There is no error, it will be indicating with a tick mark. Then we will invoke the ring counter. As we invoke the ring counter, we can take it to the objects. So in objects we have the required signals. We will select the required signals. All the signals are not required for us. We'll just take whichever is required for us. So we'll add it to the wave. So it's got added to the wave here. Then I set the clock with the frequency or the time period of 25 and let it be in the rising edge. Then I set the reset initial state with the initial value of 0 of 0. Now when I run the program, I'll be able to see the first initial state 1000 over here. So once this is set, next what do I do? I change the reset from 0 to 1 so that the effect of the reset is going to be removed. And now when we run the program, we will be able to see the ring counter, 4-bit ring counter produces 4 states. So starting from 100 and next we have 0100. Next we have 0010 001. Again it starts with 1000. So that completes the simulation of a ring counter. Thank you.